Hello, everybody. I'd like to welcome you to today's Sign for Tech is webinar. Nice to see so many of you here. And today's topic is bring Sign to the cloud and specifically to Microsoft Azure. Before we come to the actual content of the webinar, let's discuss some housekeeping rules for you to keep in mind. First of all, we hope you have questions during the session. So please use the Q&A feature to ask your questions during the webinar, and we will address as many as possible at the end of the session. After this session, we will provide a slide deck along with a recording of the webinar. Therefore, please keep in mind that this webinar is being recorded. By participating, you consent to being recorded. Finally, you will receive a brief feedback survey after this session. We always appreciate your insights in how we can improve future sessions. Now that we've covered this, I'd like to introduce you to today's presenters. My name is Lucas Bischofberger. I'm currently here as Head of Technical Operations and Customer Success at Anapaya. Since I've joined Anapaya almost 8 years ago, I've had different roles in software engineering and operations. And with me here today is Alexander Nikolovsky, Senior Network Engineer from Cyberlink.
Hi, everyone. Thank you, Lucas. Hi, everyone. I'm Senior Network Engineer in Cyberlink. Been working since last year on diverse projects for Cyberlink, mostly related to SCION. And yeah, I'm glad I'll be able to present you today the part of SCION projects and how we deal with it. Let's go to the first a brief explanation, just the introduction. Who is Cyberlink? Cyberlink is a Zurich-based MSP focusing on infrastructure services for business customers. We provide connectivity services like business internet, private network, and SCION services. Complementary to our connectivity services, we offer data center infrastructure services such as cloud and co-location. As a business provider, we have a strong focus on security and compliance. One of our USPs is access to many different carrier networks. Within each project, we integrate the cutting-edge network technologies with the right architectural approach to deliver services tailored to our customers' requirements. Of course, SCION is one of these network technologies that enables us to comply with the highest requirements and standards.
Thank you, Alex.
Thank you
for the introduction. Now let's get started with the cloud. And for this, I'd like to start with a quick high-level overview at the cloud ecosystem. The cloud is ubiquitous, and certainly everybody knows the cloud nowadays and uses it directly or also unknowingly. And certainly also everybody notices if the cloud is down, like in the last few days, we had interesting reminders of that. So everybody with an internet access has today access to the cloud. And also many of us have seen the data centers that are standing around our cities or have even been inside one of these data centers. But there is not a single cloud. There are many different providers of cloud services. All of us know the big players like AWS, Azure, or Google Cloud. But there are also more regional players like OVH, Scaleway, Hetzner, just to name a few. Also local players, for example, in Switzerland, Exascale, Infomaniac, or CloudScale. All of these clouds have different advantages or disadvantages and are chosen by businesses for different reasons. Whenever someone accesses data on these clouds via the internet, though, they have the same weaknesses inherited from using the internet. There is lack of visibility and control of the data in transit, meaning one cannot control how the data actually gets to the data center and back. And also, when using the internet as an underlay, we can always be affected by the inherent problems of BGP, like prefix hijacking or conversions times of BGP. Some of these clouds offer the possibility to build a dedicated cloud interconnection, called Express Route or Direct Connect or similar. And while these fix some of the problems, to connect to the cloud, they're rather expensive and inflexible. Now here is where SCION comes in. And the good news is SCION can connect to basically every cloud out there. And there are different ways to do that. We usually distinguish them by where the SCION connection terminates. The first one is as close to the cloud as possible, and we'll see an example of that later, or inside the cloud environment itself. So, for example, inside the virtual private network of the customer in the cloud. And we'll also focus on this afterwards. And to give you a brief overview of the SCION cloud ecosystems, there are different clouds where we publish the SCION network, virtual network appliance, like the Anapaya Edge, that can directly run inside the cloud, for example, AWS or Azure. And there are quite a few other clouds where we have customers and partners that have successfully run SCION in the cloud as well. We are expanding this list upon demand and working on enabling native SCION connectivity into as many clouds as possible. And all the other clouds where we don't have SCION running inside the cloud at this moment, we can always bring the SCION network as close to the cloud and connect via a private interconnect. We'll now have a quick introduction to SCION, what it does and how it works. On a very high level, SCION can be described like traveling the internet with a GPS. And to make an analogy here, on the traditional BGP-based internet, a packet is sent from start to end, and on every router on the way, on every BGP router on the way, it's checked against the routing table to see where it should go next. So this is like a compass that every so often you check if you're still going in the right direction. On the SCION internet, the network itself provides the sender information about all the possible paths in the network, how to reach the destination, and the sender can select the best path before it even starts traveling to its destination. So like with the GPS, you can decide on the best path for your personal requirements before you start the journey. So how does SCION do that? Here I'd like to focus on 3 features of SCION: isolation domains, control plane, and the data plane. First, the isolation domains. SCION groups autonomous systems, like ASs, as we know them also from the BGP world, into a group with a common trust root. This gives isolation on the trust level. As an example here, the SSFN, the Secure Swiss Finance Network, is governed by SIX and the SMB, and they can define who is part of this group of networks and who is allowed to join the network and communicate. Second, the control plane. This is the brain of SCION. This is the part that discovers the entire topology, discovers path segments that can be used to route from A to B, and makes them available to the end users of the network. On the data plane, a user that wants to communicate in the SCION network takes this information from the control plane, takes these path segments from A to C, puts them in the packet, and tells the packet how to reach its destination. And every router on the way sees this packet and just forwards the packet along the path, along the predefined path in the packet. Now, how does a SCION internet actually look like? It's actually quite similar to a BGP internet. In the center here, we see the backbone of the network, the carriers, the ISPs. They run core routers. These are the SCION routers that are the waypoints in the network. They forward the packets along the way that they are supposed to travel along. Around this backbone, we see the users of the network. We see companies that want to communicate with their partners, branch offices that are connected, all IoT devices or clouds as examples. The branch offices or the data centers, they're connected via Anapaya Edge. The Edge is a gateway to the SCION internet, and this is where the path selection happens, where one can define how they want to travel the network. And then there is the gate. These are the entry points for end customers, end devices, IoT devices, which don't run SCION themselves, but still want to be able to communicate in the SCION network. Now today, as part of this webinar, we'll focus on these two parts, on how we can connect the cloud using an edge to a SCION ISP with these two different topologies. And with that, I'd like to hand over to Alexander, who will explain you how the SCION integration works.
Thank you, Lucas, for this great introduction. In this part, I'll explain how SCION can be integrated into cloud infrastructures such as Microsoft Azure. We'll look at the integration models, a reference infrastructure, and the proof of concept we validated in Cyberlink's environment. The goal is to give you a clear understanding of the different options available so you can select the approach that best fits each project scenario or customer requirement. There are basically two connectivity models for SCION integration. So one is on-prem and the other one is cloud-hosted edge. In option one, the on-prem edge in this setup, Anapaya is deployed at a SCION provider's data center. Customer connects to the SCION provider's data center with the express route, and then SCION provider sends SCION prefixes from edge to the cloud via BGP. And this approach is ideal when an organization needs to connect multiple regions to the SCION network, for example. We have successfully implemented this model across several customer environments and cloud platforms, making it a proven and reliable approach. The additional cost, which is related to rack space and electricity of physical edges, must be taken into consideration. Now, the option two is a cloud-hosted edge, what we see on this slide. So in this setup, Anapaya Edge is deployed directly in Azure in the VNet, allowing workloads to connect to SCION natively, but without backhauling through on-premises infrastructure. This means that all the traffic from the cloud to the remote endpoint can be encrypted, for which an Anapaya Pro license would be required. This option fits customers who have one or few VNets within the same region that require SCION connectivity or prefer not to manage private connection themselves. In case the customer wants to connect to provider's cloud edge in order to avoid installing a private connection, customers' application VNet peering can be made with the SCION provider's SCION edge VNet. And all SCION prefixes sent to the customer's VNet via BGP or by using static routes, depending if single or cluster edge is part of the use case. Several customers requested this model, so we made it the focus of our POC with Anapaya to validate it in practice. In the case of an edge cluster, of course, bear in mind that Azure route server cost must be considered. And in both cases, SCION edge advertise local and receive remote IP prefixes via SGRP protocol from other edges in the SCION network while using SCION as the underlay, and then all prefixes are re-advertised to the cloud VNets via BGP. On this slide, we'll briefly explain the on-premise edge. So on the left-hand side of the diagram, you can see the application VNets from which all SCION-bound traffic would utilize express route and service provider infrastructure via IP network in order to reach on-prem SCION edge, which is in SCION provider's DC part of the slide. where IP packets would be encapsulated into the SCION packets and then transferred via SCION network until they reach destination SCION edge, where IP packets would be decapsulated again and sent to final endpoint. All IP prefixes between source and destination edge are advertised via sGRP protocol, which we will explain a bit more in detail in the next slide. Option 1, as mentioned, can be implemented on any cloud platform, making it both straightforward and quick to deploy. The only requirement is to establish a private connection between the cloud and the SCION provider's data center to achieve IP reachability to the edges. Option 2 is presented in our case in two sub options. First option would be when the IPv6 backbone by service provider is involved, and the second option would be when service provider has IPv4 backbone. So in this case, IPv6 with the IPv6 backbone, the option 2.1 involves a virtual SCION edge, which you can see now on Azure customer section of the slide, or cluster deployed in a dedicated VNet to which all VNets requiring SCION access are connected through VNet peering. In the case of a single SCION edge, static routes can be used, whereas for cluster, SCION prefixes can be advertised into each VNet using the Azure route server. The SCION edges use the IP network between the VNet and the SCION provider's core to establish the SCION tunnel overlay to SCION core. This option excludes virtual WAN when the SCION provider's backbone supports only IPv6. Option 2.2 differs from 2.1 only and virtual WAN integration. So virtual WAN can be part of the design when the SCION provider's backbone supports IPv4, since virtual WAN and of course the Azure route server support only IPv4. So this must be taken into consideration when designing the final customer solution. So together with Anapaya, we validated option 2.1. Since the IPv6, the Cyberlink backbone is based on IPv6. Our goals were to create a solution that meets the security, resiliency, and availability standards required by Swiss financial and government institution, while ensuring stable paths, clean route exchange, affordability, and operational simplicity for support teams, of course. The result is a production-ready solution. On this slide, we're presenting high-level architecture overview and all the elements. So all the components that form the architecture used in our POC, which we'll cover in more details in the next slide. So here we'll go more in depth to the POC setup. A dedicated VNet in the left bottom part of the diagram is hosting the SCION edge cluster, which is logically segmented into data management and LAN subnets. LAN interface on SCION edge is facing application VNet and provides SCION access for all SCION bound traffic. This interface is also used for BGP session with the Azure route server, which will be explained later on. Or in case of static routing, it would be used as an X hub for all SCION prefixes. Management interface is used for managing the edge, whether by service provider or by a customer, depending on the agreement. SCION data interface is used for edge to core connectivity. So we established core to edge reachability via IPv6 aligned with our backbone to validate dual stack behavior end-to-end. IPv6 connectivity was used as the underlay for building SCION tunnels, while the SCION overlay was used for edge-to-edge IP prefix advertisement via SGRP. Basically, to clarify, how are we establishing end-to-end IPv4 communication if edge-to-core backbone runs on IPv6 without using a dual stack? IPv6 backbone is only used as an underlay for building SCION tunnel between edge to core, which will extend the SCION network to the edge. And then SGRP, so SCION Gateway Routing Protocol, which is used for advertising IP prefixes over SCION, uses SCION network as the underlay. So having this in mind, IPv6 backbone is completely transparent to SGRP, meaning that applications can communicate with remote endpoints on IPv4, IPv6, or dual stack, whichever is configured on edge LAN interfaces. From VNet and the edge setup perspective, the setup is straightforward. The SCION edge runs in its own VNet, while applications remain in their respective VNets. This allows repurposing SCION access for multiple VNets by simply peering them to the edge VNet. Routing Azure SCION bound traffic uses the edge path, while regular cloud traffic follows standard egress policies that are set. From an application standpoint, SCION is completely transparent. Applications reach the edge like any shared IP-based service. SCION VNet would become a hub VNet for all spoke application VNets that are peering with it, whether through normal or cross-account peering. Bear in mind that peering is not transitive, so you need to configure right permissions and apply right peering settings in order to make SCION Edge Hub VNet transit to express route for all spoke VNets. When setting up Edge in Azure, make sure just to use the latest Anapaya image and follow the installation guidelines provided in the Anapaya knowledge base to size the VM where Edge will be hosted correctly and avoid the deployment issues. Just to check about the Azure route server. So in our POC, we also validated dynamic route exchange, allowing application units to automatically learn IP prefixes from other SCION participants. This eliminated the need for manual static routes and reduced configuration drift. Operationally, this results in less manual effort, faster onboarding of VNets, and consistent traffic engineering towards the SCION network. Currently, Azure Route Server is available only in selected regions and supports IPv4 only. So this must be considered during the solution design. From setup perspective, the route server, which is hosted in application VNet, so on the customer side, establishes BGP sessions with both edge cluster members, advertises local VNet prefixes to edges, and installs SCION prefixes learned from the edges into the application VNet routing table. And all the installation guidelines can be found in Microsoft knowledge base. So just to go through the actual benefits. We would mention, so the first point, enhanced security and attack surface reduction, which involves immunity to BGP hijacking, DDoS prevention, and end-to-end encryption for edge running in the cloud. Second would be control and data sovereignty, regulatory and jurisdictional control, end-to-end visibility, and path transparency. Third point would be a resilient connectivity, which includes multipath connectivity and immediate path failover. And the last but not least is seamless integration, which includes no change in the network architecture needed and transparent transport for all applications. Thank you.
Thank you very much, Alex. Now, before we come to the questions, I would like to reiterate the key takeaways that you should take away from this webinar and keep in mind. First one, SCION integrates seamlessly with cloud environments such as Azure, extends routing security, path control, and resilience to the cloud. Generally, we can say that the discussed implementation blueprints that Alex showed are mostly cloud and provider agnostic and can easily be replicated into other clouds. Second, there are two proven connectivity models. First, bringing SCION as close to the cloud with an on-premise edge as possible. A connectivity model that works for almost all cloud environments out there. And second, bringing SCION into the cloud using a cloud-hosted edge, where we have the benefits of end-to-end encryption into the cloud, fast failover and path control into the customer cloud network, into the VNet of the customer itself. And both of these models have been validated with customer projects running on different cloud environments through collaboration between Anapaya, SCION providers, and cloud architects of these clouds. And with that, I'd like to thank you again for the attention, for being here today. And if you're interested in getting in touch with Cyberlink about connecting to your cloud, please scan the QR code here. Thanks again for being here and your attention, and hope to talk to you soon.
Thank you, everyone. Have a nice day.